Hello all, welcome to this class on development of lateral surfaces of solids, and in this class let's solve this problem number 5, that is in development of lateral surfaces, that is draw the development of the lateral surface of a funnel consisting of a cylinder and a frustum of a cone. The diameter of the cylinder is 20 mm and top face diameter of the funnel is 80 mm. The height of the frustum and cylinder are equal to 60 and 40 mm respectively. Okay, here, I mean, generally in every problem, what we were doing is before drawing the development on the right hand side, we used to draw its front views and top views. So similarly, even here, we are going to draw the front views and top views of this, this funnel, that is funnel has the two parts. The top part is a frustum, the bottom part is a cylinder. So we are just going to draw its front view. So cylinder's front view will just nothing but be a rectangular in shape. Here you can just see cylinder's dimensions are clearly given. The diameter of the cylinder is 20 and height of this cylinder is, they are giving frustum and cylinder are 60 and 40. Therefore height of the cylinder is taken as 40. So when you are taking it as, therefore the front view of the cylinder will nothing but be a rectangle. So that you can just take this rectangle, you can consider this rectangle, give the width of the rectangle as 40, enter, and okay, you can yes, and give the height as 20. So when you just okay, just give the reverse. So give the width as 20 because depth is what they're trying to give. So give the height as 40. So then give the angle as 0 and then just place it over here. So give the angle as 0 and just place it over here. So you just get that. Give the width as 20 and the height as 40. Remember, width is 20 and height is 40 because they are mentioning it clearly here. Height of the cylinder, that is height of the frustum and cylinder, 60 and 40. Therefore, height of the cylinder is 40. So using smart dimensioning, you can try to you can just try to make a note. You can show it the dimensions also. So here you can just see here it is not shown correctly, but here in this box you can see that it is shown as 40. And this one will be 20. You can show in the exams whenever clearly. So see that here it is showing that isometric dimensions, so I'm trying to delete that, but in the exams you can try to show it. Then using a center line, what you can do is go exactly the middle, just draw a center line. And okay, now from the center line we'll have to draw the height. We'll have to give height of the frustum as well. So this is the cylindrical part, front view of the cylindrical part. Similarly, front view of the frustum, when you're trying to draw, height of the frustum is nothing but 60 mm. So from here let me try to give 60 mm, enter 60, enter, let it be 90 degrees and let it be like this, and then just click it, left click and then right click. Now what you will have to do it is give the diameter of the cylinder, diameter of the diameter of the frustum. You can just see top face diameter of the funnel is 80 mm. So go to line, visible line. So from here, that is from the center, it has to be 40 on either side. So that is total is 80, therefore 40 on either sides. So 40, enter, left click and then right click. Similarly keep at the center again. So go on the other side, 40, enter. Now what you can do is join this line to here, to this corner of this rectangle. Similarly join this to this corner. Next you can go to this extend to next option and just extend this line. So now it has extended till here. So with this we have just completed this front and top. Using the smart dimensioning, you can just show all these dimensions. You can show this dimensions. You can try to show all these dimensions also. This dimensions also, if you try to show, it is found to be 89.44. And similarly, you can try to split this line at here so that it might be very, very helpful later. Those dimensions, all those dimensions you can try to show, because here I could not show it as I told, it is showing isometric. So here I can't show it. And what you can do is you can try to split that now itself, so that because this inner part, these two lines has to be shown normal. So you can try to split at this part. Okay. Similarly, this line you can try to select it. That line is, as I told, okay, you can try to select that later as well. But for now you can just leave it off this. Next thing what you can do is do the development. So do the development of first do the development of this cylindrical part. So cylindrical part, when you try to unfold it, it will be the form of a rectangle. So rectangle's height will be 40, but what will this I mean the rectangular's length be? So cylinder, when you try to split it or try to unfold it, I mean you can just take the length to be equal to the circumference of it. So it is, you can just take the circumference, that formula is 2 pi r. So 2 into pi into r. R is nothing but radius of the cylinder. Diameter of the cylinder, they are telling already it is 20. Therefore radius will be 10. So 2 into pi into 10 will be 62.8. So what you can do is go to rectangle. So something corresponding to this, using this using this alignment indicator. So just draw a rectangle. I mean, you can just enter it here directly. So rectangle's width you can enter as 62.8, and see, height you're entering it as 40, the same height. Enter and give the angle as angle. You can try to give 0 degrees. That is not a matter. So see exactly where you're entering is. You can exactly enter it here. So what you can do first, give this first. You can just give the width as 62.8, enter. Height as 40, enter. So that is also enter. Exactly something corresponding to this. You can just see here, corresponding to this, I'm trying to enter it. Okay, now corresponding to this, I just placed it over here. So now you again using this smart dimension, you can show this. So this will be 40 and this will be 62.8. Now we will have to show the, what to say, development of this frustum. So when you're trying to, what to say, unfold this unfold this frustum, you're going to get that. So you see, using first this dimension, you can measure this dimension as I told you earlier, that is found to be 89.44. So what you can do is take a visible line. First draw a line. So let that length be 89.44. Enter. Just click. Then draw another line. So let that line also be 89.44. Okay. At some angle. Let's leave that angle for now. Okay. Let me draw it again. So draw it at some angle 89.44. Okay. So now we will have to draw a arc, but before that we'll have to say measure the angle between this. So the angle between this that angle is nothing but this cone angle, because this frustum will have some angle. So similarly, even when you're trying to unfold it, it will have some angle. That angle is nothing but you can find it by using theta equal to small r by capital R multiplied by 360 degrees. So that is nothing but the formula. So small r by capital R. Capital R is nothing but this 89.44. That is nothing but I mean capital R. But what will small r be? So small r is nothing but it is nothing but 40. So 40 value. 40 is nothing but the I mean diameter of that funnel. So I mean radius of the funnel. Actually diameter of the funnel is nothing but 80. Therefore small r will be 40. So 40 divided by 89.44 multiplied by 360 degrees. When you're trying to do that, you're going to get the angle as 161 degrees. In the exams, if a similar question is asked, even you don't have to show all that. You can directly remember it as 161 degrees and try to do that if the dimensions are same. So now what you can do, after drawing these two lines, go to angle between, measure the angle between these two as. So it is here, you can just see in this table it is showing 153.56. Enter it as 161 degrees and just try to enter. So now it is exactly 161 degrees here. So you can just show it in the exams, but here I'm trying to delete as I could not change the isometric dimensions. So now what you can do, go to this arc by center point, arc by center point. So click at this end and so you can just go to this arc by center point. So let this be the center. Okay, let this be the center and let this be the starting point and end here exactly. So this one with 89.44, we just drew that. Next thing what you'll have to do it is, as I told you earlier itself, you have to split this line. We have already split that line into, see, this one is a separate part and this one is a separate part. So this one is a separate part already and this one is also a separate part. So when you're trying to measure that length, so that length you can just measure it. So that length is found to be, let's try to measure that length. That length is found to be 22.36. So here you can just see in this box it is mentioned as 22.36. Again what you can do is go to arc by center point and keeping this as center and enter the radius as 22.36. Enter. Cut another draw another arc. Now what you will have to do it is only this particular part has to be made visible. So you see in this smaller part, that one has to be made normal, using normal line. So again you can try to use the split option, split that line, click this line and split here. Similarly, click this line and split here at this wherever this arc is cutting that line. Now what you can do is select this line and make that normal. Similarly, select this line and also make that normal. So now you can just see this is done. So this is nothing but the development of this frustum, and this is nothing but development of the cylinder. So that's it. This is the most shortest problem that you would ever have. So I hope you understood this. Thank you.